All right, let's go ahead and pray.
There's like Bentley dealerships, Lamborghini dealerships all over the place.
Dear Father, we just thank you for the day, the blessings you've given us. Thank you for the students here. Thank you for keeping us healthy. Just pray you may help us in this class this week as we prepare for Thanksgiving holidays. Just pray you may guide and lead in everything we do. In Jesus' name, amen. All right, questions on your homework?
Yes.
No way.
Well, it's just a little confusing. I forget what the factor theorem for number 19. How exactly do you do that again? I just need my brain refreshed.
Divide is the remainder 0. It is a factor. If the remainder is not 0, it is not a factor.
That's all I had to do?
Yeah.
Oh, I didn't know it was that simple. Oh,
You have to do 19?
Yeah.
No.
You start at 1. It's 1 to 15.
No, 3 to 55.
I did the wrong homework. I did 1.
That was the one from the night before.
Well, I did 3 and I had 19.
What? 6. 9 plus 6 is 15. Yeah.
Time out. Mr. McLaughlin.
Because it's 3, 0.
What was the homework on Friday night? I'm going to look it right away.
3 to 55.
I don't think that's
Every
right.
other
I'm refusing to believe it.
No, it's every other odd.
Yeah, every other. What?
Yeah.
Where's my iPad?
Ma'am,
39.
39.
Well,
Yeah, we haven't talked about that yet, so I'm going to do it today.
Good. My
Yeah.
question. And like 31 through 50.
Yes. The upper bound and lower bound we haven't talked about yet.
So we got to do 3 through 50. What now? Odd? Not every other odd?
I couldn't
No, it's every other.
Yeah, that's what I had.
Yes, there was 3s. There were 3 O's after the E.
I saw
There were 2.
There were 3.
There were 2.
You tell us. I want my iPad.
Jessica, didn't you take a picture?
My iPad had 2.
But the board last week was 2. 3.
It was definitely 3. Because I wrote it down for once in my life, and apparently I wrote it down wrong.
Oh.
Well, if you just procrastinate and then look at the run web, it's 3.
What were the problems?
3 through 55.
Yes.
Oh, wait, it was 3.
Every other.
Oh, yeah, it's picture at the beginning of the week.
Were there 3 O's?
Yeah.
Yeah, sit down, Jessica.
For once.
All right, that's fine.
Well, okay, I did more work than
If you did more, that's fine.
That's not ha, that's a ugh.
All right. Any other questions?
Both look good as one.
So,
Very good.
Oh, 45. So like the upper and lower bound type of something.
Yeah, we're going to do that.
Okay.
So anything after 39 we're going to do today?
After 39, well, 37 to 44, or 37 through 48, we haven't talked about yet, so.
Okay, can you do 31?
31?
Yeah.
All right, what's my zeros?
-4, 3, and 5.
-4, 3, and 5. So therefore my factors are what?
X plus 4, x minus 3, x minus 5.
All right, they want a lead coefficient of what? Oh, they didn't say, okay. All right, they told us that when x equals 0, y equaled
180.
180. All right, so you put 0 in for all the x's, you get 180 equals a times 4 times -3 times -5. So that's 180 equals a, that's -12 times -5, which is 60. So therefore a equals 3. So y equals 3 times x plus 4 times x minus 3 times x minus 5. Alright, so you're almost there. Just have to plug in the 0 and solve for A.
11, 13, 15.
Any other questions? Everybody good?
13, 19, 21.
Alright. Lower bound and upper bound. I will in just a few minutes. Lower bound and upper bound. Alright, when we talk about lower bound and upper bound, if this was my viewing window on my calculator, and I had this is my viewing window. Well, how do I know if the graph comes back up or this actually goes up? Because sometimes if I don't have my viewing window wide enough, we don't see these points here. Sometimes we miss this point here. Well, my upper bound and lower bound tells me that past this point, there are no other zeros. That means it does not come back. So take, for instance, this was my window here, and this was at 5. 5 would be an upper bound because this graph is not coming back through. So this would be the biggest zero I would have on the positive side. My lower bound here, if this was -3, well, -3 would not be a lower bound because it actually comes back outside the window. So our goal is, when we're trying to figure out upper bound and lower bound, is to figure out, all right, does it come back or does it not come back? So we can do that by synthetic division. And I have an upper bound. Let's take, for instance, this is my synthetic division, and I had 5, and I had a positive, a positive, a positive, and a positive. And all those numbers were positive, then this number would be a upper bound, because it does not come back. Alright, now these could be zeros here too, so non-negative, put it that way, non-negative. If I had -3, and it came out to be positive, negative, positive, negative, and all of them alternate, then it is a lower bound. That means that's the smallest number a zero could be. So let's look at an example here at 2x to the 4th.
Did you say it needed to be alternating like that?
Yes. Now, it doesn't matter if it's negative first or positive first, as long as they alternate.
To be what?
A lower bound. Alright, so here, we have this polynomial, and I want to find out if this polynomial can be completely in my window between -2 and 5. So I want to find out, is -2 a lower bound, and is 5 an upper bound? So I'm going to use my synthetic division. 2, -7, -8, 14, and 8. And let's try 5 first. Put 2 in. 2 times 5 is 10, plus -7, 3. 5 times 3, 15, plus -8, 7. 5 times 7 is 35, plus 14, 49. And 5 times 49 is 245. So I get 253. here. If I notice I got positive, 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 so yes, 5 is an upper bound. There is no other zeros past 5. If I do negative 2, and put negative 2 in, bring the 2 down, negative 2 times 2 is negative 4, plus negative 7 is negative 11. Negative 2 times negative 11 is 22, plus negative 8 is 14. Negative 2 times 14 is negative 28, that's negative 14. And negative 2 times 14 is 28, that is going to be 36. And if I notice I got positive, negative, positive, negative, positive, so therefore negative 2 is a lower bound. That means negative 2, there's no zeros below negative 2. So for it to be an upper bound, I must have all non-zeros, all non-negatives. And for it to be a lower bound, I must have alternating numbers.
Don't do it. Oh, okay.
Excuse me?
Nothing.
You good?
Yeah.
You sure?
Yeah.
Alright.
So it means that there's no zeros past that number?
Correct.
Alternating zeros? Or signs? What was lower bound?
The numbers alternate. Positive, negative, positive, negative, positive, negative.
So alternating sign?
Positive, negative, positive, negative, positive, negative.
What about negative, positive, negative, positive? Does it really matter about which order the positive and negatives are in?
No. So if we look at this one, we're looking for that k equals 3. Is this an upper bound? So use a synthetic division, 2, negative 4, 1, and negative 2. Bring down the 2, 3 times 2,
6,
plus negative 4,
2,
3 times 2,
6,
plus 1,
7,
3 times 7,
21,
plus negative 2.
19.
Is 3 an upper bound?
No.
Yes.
Yes, yes. Sorry.
Because they're all non-negative.
Yeah.
What if it's negative, negative, and then positive, positive? It's not, it's neither upper bound nor lower bound?
A result is non-negative, then it's upper bound.
I mean, like in case like what if it's negative, negative, and then positive, positive?
Is it all non-negative?
No.
Therefore, it's not upper bound.
Not like lower bound, right?
We're not looking for lower bound, we're looking for upper bound. Is it an upper bound? Correct. Alright, let's look at another one.
Oh.
Did you rip my book?
Yeah, she did.
I
Whole
just
thing
did
just
that
ripped.
book cover.
Whole thing, the whole cover just ripped off and smoked off.
I said you should be helping me.
I think it's burning right now as we speak.
Alright, you should be helping her. Be a gentleman.
Chivalry's dead.
Alright, looking for if 2 is an upper bound.
Equal rights, equal fights.
Alright, 2 times 1 is 2, plus negative 1 is 1. 2 times 1 is 2, plus 1 is 2 times 3 is 6, plus 1 is 2 times 7 is 14, plus negative 12 is 2. Is 2 an upper bound?
Yes.
Yes.
K equals.
Another one?
Another one. What's to dust?
K is negative 3. We're checking negative 3, bring down the 1. Negative 3 times 1,
Negative 3.
plus 2.
Nah, 1.
Negative 3 times negative 1, plus 2. Negative 3 times 5,
Negative 15.
plus 5.
Negative
Is -3 a lower bound?
Yes.
Yes, because it alternates positive, negative, positive, negative. So it is a lower bound.
So every time you see all positives in the top and then a negative thing to plug in,
Now, don't worry about the top.
I know, but I'm saying, will it always be alternating and be lower bound?
Not necessarily.
Okay.
Depends on what the numbers are. Because if this was larger than 2,
Mhm.
then that would have been a positive there.
Mhm. Mhm.
So it wouldn't be. Alright, so this will help when you're looking for zeros, because you're testing out your numbers and you all of a sudden you're going on the positive side and you get all positive, then you know you don't need to try anymore the positive because it's an upper bound, there's no more zeros. Same thing on the negative side, if you're going down negative and you get alternating numbers, then you don't have to try anything smaller than that number because you have a lower bound.
So you would try -2, -1, 0, 1, 2, 3, 4 for that one.
Well, here I wouldn't try any numbers lower than -3.
Yeah.
Here I wouldn't try any numbers higher than 2.
Mhm.
So because you know it's not going to work, they're just going to keep getting bigger and bigger and bigger.
Mhm.
So, all right, let's look at one more.
Maybe we all pop them up.
All right, well, let's see if this is a lower bound. So we get 3, -1, -5, and -3. -4 in. Bring down to 3. 4 times -3. -12. -1 is -13. 4 times -13. -4 times -13. 52. 52 plus 5 minus 5 is 47. -4 times 47 is a large negative number, plus a -3 is a negative number. So I get a positive, negative, positive, negative. Is -4 a lower bound? Yes, it is. If we look at number 46, or let's look at number 45. Number 45, we got 6x to the 4th minus 11x cubed minus 7x squared plus 8x minus 34. They're asking for, use the upper and lower bound test to decide whether there could be real zeros for the function outside the window.
Ooh.
If so, check for additional zeros.
We didn't have to do 45 in the homework, right? Right. Yeah, okay, good. Just making sure. The sunshine on a cloudy day.
Alright, so we're going to use this in thick division. Alright? We're going to check for our upper bound. Is there an upper bound? What number will we test?
-1. -2.
If we're looking for upper bounds,
Oh.
5.
5.
That's the edge of the window. Alright, because we want to see if this comes back down outside the window. So we put 5 in. 6 times 5? 30 times -11? Or plus -11 is 19. 5 times 19, a big positive number, plus a negative would be a positive. 5 times a positive would be a, alright? And so here, I guess we need to do it further, I guess. So let's do it. 5 times 19, that's going to be
94.
95,
95. Dang it.
plus -7, 88.
Oh, yeah.
5 times 88, 280.
440. 480. No, 440. It's 440.
440,
Yeah, 440.
that 440,
Yeah.
that's 448.
Man, I'm stuck.
And then 5 times 448 plus a negative, this would be a positive. So is there any number past 5?
No.
No. Alright, If I want to check the lower bound, what number will I test? Negative 5? We've done the 6.
So is upper bound?
5 is an upper bound because they have all positive.
We're not done yet.
Alright, so now we want to check the lower bound. So we bring down to 6. We're gonna stay at the top. Negative 5 times 6.
Negative 30. Negative 41.
Negative 5 times 41. Negative 41.
Positive 95. No, 365. No, 205.
205.
I'm really tired.
You're
198. Negative 5 times 198.
I drove home yesterday from Christiansburg.
Alright,
Uh,
that's opposed to a negative 1,000, correct? So it's gonna be a negative 1,000 something. And we're gonna get negative 5 times negative 1,000 would be,
Positive.
so it's gonna be a positive number. So we get positive, negative, positive, negative, positive. So is negative 5 a lower bound? So is there any zeros outside the window?
No.
No zeros outside the window, correct. Alright, let's look at number 47. And we got next to the 5th. Alright, so let's use our synthetic division here. We got 1, negative 4, negative 129, plus 396, negative 8, and 3. Alright, for our upper bound, what are we going to test?
5.
We're going to test 5. Alright, 5 times 1,
5.
5 plus negative 4. 5 times 1,
5.
plus 120, negative 129, negative 124. So is 5 an upper bound?
No.
No, so there's a 0 that's beyond 5. So we'll come back to that. Alright, let's test the lower bound.
Negative 5.
Want to test negative 5? So negative 5 times 1.
Negative 5.
Negative 5 plus negative 4.
Negative 9.
Negative 9. Alright, negative 5 times negative 9.
45.
45 plus negative, and we have a negative. So is negative 5 a lower bound?
No.
No, it's not a lower bound. So they ask, I say, let's find the zeros that are not shown. The zeros that are not shown. What zeros do we know?
1.
0, 0, and 3.
Alright, so let's go ahead and bring in the 3. Bring down the 1. 3 times 1
3,
plus negative 4. 3 times negative 1 plus negative 129.
Negative 332. 132. Sorry, 132. Man,
3 times negative 132.
today's a good day.
3
396.
times 0.
0, 8. 4, negative 21.
It doesn't work.
Uh-oh, he's not happy, it doesn't work.
I'm not happy. Why is that?
That's negative 7. Oh, no, yeah, that was negative
3,
1. Yeah, that's
negative
negative
1, negative 132, negative 396, except 0. 0 plus negative 8 is negative 8. Negative 24 is negative 21. So it must not be exactly 3. Because it's not exactly 0 either. You're not supposed to use, you shouldn't have to use your calculator. Oh, you know, no, that's not right.
I got lost in the woods
There was
this
a
weekend.
negative one.
That was a fire
Yeah.
close by me.
Did you go calculus?
I was lost 15 miles. I walked like 15 miles. Like over all these mountains. It was a good time.
5, 4, 3, 2, 1, 0.
Yeah.
Get anything?
No, my friend did though. He got an 8 point. And then I drove home yesterday, and this tractor trailer truck was like pulling off of 81, and he like overcorrected, and the back of his trailer hit the guardrail. You know, like huge. It was great. And
Alright, so I'm not gonna worry about that, because evidently the graph is not as accurate as it should be, because it looks like 3 should be a 0, and it looks like 0 should be a 0, but I know 0 is not a 0 because you should have a x with a 3. Alright, so we won't worry about that. Long as you can find that it's not an upper bound and it's not a lower bound. That's what I'm more concerned with. Alright, is it an upper bound or is it a lower bound? Okay? Let's look at another example. Let's look at number 55. Let's take that back. Let's look at number 54. All right, so what are all my possible zeros?
Plus,
Uh,
plus or minus 5, plus minus 2.
plus or minus 10, and then 1/2, right? No, never mind.
Because first
Yeah.
factor is only 1,
Yeah,
so everything's over 1.
yeah.
All right, so we want to find all our zeros. Which number you want to try first?
Let's try -5. I don't know.
Might be a method to your madness, I don't know. All right, -5 times 1.
-6. It's not in.
-6.
Yeah. Then +30, so -23. I mean, no, it'd just be 23. Sorry, man, this has been a rough day. 115. Nope, it doesn't work. Nope. Then 515. Plus 10, 560.
All right, what does that tell you about -5? It is a lower bound. So there's nothing passing. You know we're not even going to try -10.
You're welcome.
All right, give me another number.
Let's go 2.
+2.
Sure.
Why go +5? That's lower.
2 times 1
2,
plus -1.
1,
2 times 1
2,
plus -7.
-5,
2 times -5
-10,
plus 5.
-5,
2 times -5.
-10.
Oh, I see what you're doing, Isaiah.
Yes, sir. Got him.
We're going to try now. Is one of these zeros?
You try. You try +5 to see if it's where the
No,
upper
it doesn't
bound
work,
is.
doesn't work.
You know it doesn't work?
Yeah.
Oh, we just find zeros. Okay. Let's try -2.
-2 times 1.
-2.
Plus one.
-3. -3.
Remember -1.
Wait, what?
Plus,
Oh, you're not looking at the top anymore. My bad.
-2 times -1.
2.
2 plus -5.
-3.
-2 times -3
6.
plus -5.
1. Oh, we were so close, but yet so far. Try
I
1.
think this is my least favorite part of the math.
1 times 1
1.
plus 1.
2.
1 times 2
2.
plus negative 5.
Negative 3.
1 times negative 3
Negative 3.
plus negative 5.
Negative 8. Man. Negative 1.
Is there,
What's that
is
one?
there a shortcut to synthetic division?
Nope.
Synthetic division is a shortcut.
The synthetic division is the shortcut. Negative 1 times 1
Negative 1.
plus 1.
0.
Negative 1 times 0
0.
plus negative 5.
Negative 5.
Negative 1 times negative 5
Positive 5.
plus negative 5.
0.
Alright, so this
Don't lose your marker there, Mr.
this equation is
x squared minus 5.
solve this.
X squared equals 5.
Plus or minus.
X equals plus or minus 5. Square root of 5, sorry.
So what are my zeros? My zeros are 2, negative 1, plus or minus square root of 5 are all my zeros. Alright, I got two real rationals and 2 irrational.
What does that mean?
Square roots.
I know what that, I meant like what rational, irrational meant. I
Well,
meant,
they'll ask you what if they're rational or irrational.
okay.
So you get 2 rational and get 2 irrational.
I don't know, like the irrational meant like there's something special about the graph.
Any questions there?
No. On a cloudy day.
Everybody good? First time I get left.
13.
Alright, so your homework tonight is just more of that. You are doing 4 through 52 multiples of 4 tonight. I want to talk a little bit about complex numbers. I know I won't get it all done tomorrow, so I'll take part of it today and part of it tomorrow. Complex numbers, complex zeros. Complex numbers is a real and an imaginary put together, correct? You know, 1 plus I is a complex number. I is a complex number. We can put all our numbers in the form of a plus bi. I can put 5 in the form of a plus bi, that's 5 plus 0i. I can put negative I in the form of a plus bi, that's 0 minus I. So we have complex numbers. My degree will tell me how many complex zeros I have. So take for instance, my degree is 5. I have 5 complex zeros. 5 of them could be real, or 3 could be real, or 1 could be real. Now why is that? Because complex numbers always occur in pairs. Imaginary numbers always occur in pairs. If we look at our polynomial, we don't have i's as coefficients. So they must occur in pairs because that's the only way they can cancel out. How can I cancel out an I? By using, starts with a C, English term, conjugates. Take for instance, how do I get rid of a I? Multiplied by negative I. Alright, how do I get rid of a 1 plus I? Multiplied by a 1 minus I. So they always occur in pairs. So that's why when I have a degree of 5, 5 of them could be real. But what if one of them was complex? Can't just have 1, have to have 2. 2 complex. So that means 3 could be real. What if I had another complex? Or there can't be just another one, it has to be 2 more. So that means 1 could be real. So therefore my complex numbers always differ by 2. Just like my turning points. So therefore, if my degree is 7, how many of them could be real?
7,
7 or
3,
5 or 3 or 1. If I had a degree of 4, how many complex zeros do I have? 4 complex zeros. How many of them could be real?
2,
4 or 2 or 0. I could have 0 reals. Well, what happens when I have a complex number in my graph? Here I have a parabola. Parabola, my degrees are what? 2. How many complex zeros could I have? 2. How many could be real?
2.
2. How many do I have real here? None. Because if I had a real 0, it would have crossed the x-axis, correct? So I have none. So I basically have 2 complex zeros. 2 zeros that are I. If I would solve this by quadratic formula, I would get a I in my answers. But you notice I still have 1 turning point. Alright, my degree is 2. How many turning points do I have? Now think about it. If my degree is 2, how many turning points do I have? 1. There's always 1 less, right? 1 less. So, it's here. What is the highest or the lowest degree I could have for this polynomial? What is the lowest degree I could have for this polynomial? A 3. Alright? Because I have 1 real 0 and I have 2 complex zeros. Because I actually have a turning point that did not cross the x-axis. Just like I had here, alright, I had a turning point, 2 complex zeros. Every turning point that results in not crossing the x-axis means I have 2 imaginary or complex zeros. Alright? So then when I say complex, that means real or imaginary. So here I got a degree of 3. How many complex zeros? 3. How many real? 1. How many imaginary?
2.
2. There's my 3 zeros. They should always add up to my degree. Here, what's my degree? 2. How many real zeros? 0. How many imaginary zeros? 2. Look at another example. Alright, here's, what's my smallest degree I could have for this polynomial? 4. How many real zeros? Look at it carefully.
None.
It's 2. Because it does what? Touches. And when I touch, what's my multiplicity? 2. So I got 2 real, 2 complex, 2 complex. So my degree would be 6. 2 and 2 and 2 makes 6.
Wait, complex includes your like normal number and imaginary number?
Complex deals with real and imaginary, yes.
So
how many imaginary here?
2.
2. How many imaginary here? 2. So I could have a degree of 6. Which is even, because my even degree means my end behaviors are the same, correct? Okay? So my degree tells me how many complex. I could have how many real out of all those complex. Whatever my degree says. And then minus 2. So again, if my degree is 8, how many of them could be real? 8, 6, 4, 2, or 0. If my degree is 5, how many complex? 5. How many real? 5, 3, or 1. If I have 1 real, how many imaginary? 4. If I had 2 real, how many imaginary? Alright, my degree is 5. And I had 2 real, how many imaginary?
3.
Can I have 3 imaginary? No, because they always occur in pairs. So if I had 2 imaginary, I have to have 3 real, correct? So my real must always be in an odd number, correct? Okay. If I had, can I have 4 real and 1 imaginary here? No, I cannot. Because again, imaginaries always occur in pairs. I always have to have an even number of imaginary. All right, your homework's on the board. We'll talk more about this tomorrow.